got sound or not. But the most okay, there's a green color here. Okay, okay, I think that's a problem. There's a green color. Okay, I'm going to stop for a few minutes. Let me solve this green color issue. Saya jadi hijau Saya jadi hijau. Jadi
Prof,
hijau kan? Yep.
keluar gambar video.
Video apa?
Apa tu yang tak ada turn camera off.
Okay. Itu kejap. Saya tengah nak reset balik. Okay, start virtual camera. Alright, now it's okay. Tadi apa jadi? Just now what happened was, instead of me coming out like normal, this thing come out with me green color. So now it is okay. Sorry, a bit stressful. Okay, what happened was there's a problem with the OBS Studio. When I stream, the stream is okay. The stream to FB is okay. The picture coming out in FB is okay. But the problem is the virtual camera going to you all is coming out in the wrong color. So what I did was I switch off the virtual camera and I switch it on again, and now it is working lah. Now it is working. So okay. Before things go wrong further, let's go and start lecture. Okay. Caveat. Okay. Disclaimer. As usual. These lectures, the one after the mid-semester break, none of them are coming out in the exam. Okay, very important. They are not coming out in the exam. The whole point of all these lectures is just for knowledge, just for enlightenment, because the SKM student will be doing a final year project in the next semester. So for the final year project, for their research project, they need to do advanced analysis. So we just cover the topics under basic statistics, but enough only for them to know what information to look for and where to look for it. Okay, as stated earlier, I have two pictures here, the big me and the small me. Okay, the big me is coming from the GoPro, and the GoPro is slower than my Insta360. So my Insta360 is playing back live, so the whatever I say synchronized with my lips, but the GoPro is a bit delayed. Okay, so that's why you see the big me is slower than the small me. Okay, so my apologies for that. Once I got the correct mount for my SJ cam, I'll be using the SJ cam instead of the GoPro. The beauty of the GoPro, it is displaying everything in full. If I use SJ cam, they will not display in full, and they will have the date displayed on top and below. So it is not really clean HDMI. So, but as usual, because I can't afford, not really I can't afford, I cannot buy a mirrorless camera for 3,000 ringgit, 2,500 ringgit, because there is no way for me to justify buying that. But buying an action camera, how much is the action camera? Very cheap. It's only about 145 ringgit for the SJ cam. So that one very easy to justify. Okay, so that's why I did not buy the mirrorless camera. But looking back, maybe I just should have just saved money instead of buying the GoPro, and instead of buying the SJ cam, I should have just bought the mirrorless camera. That one will have a much better clean output. Okay. All right. Okay. So let's not worry about that. So let's start with the proper lecture. So the proper lecture, I'm going to change screen. I'm using my iTime Mini here. You can see there. I press button. Immediately I change screen, and the screen is changed to become the screen from my notebook. So there's a second notebook on my side. Okay. That's why I cannot share screen for you all. So now I'm going to start recording on your setting. Okay, because the lecture proper is going to start. Okay, now it is already recording. I hope it's recording. Is it coming out recording? Okay, now it's recording. Okay. Okay, so the red light has come on, so it is now recording. Okay, so don't worry. Okay, so now let's start with the multiple linear regression. Again, as I stated before, Ayub's lecture or Link 9's lecture is quite good. So I'm just going to utilize his PowerPoint. Okay, where to get the PowerPoint? drramel.me. Okay, so this is Ayub's lecture. Okay, to make this thing much better, much clearer, I'm just going to download it properly. Okay, so I'm going to save it on my desktop. Why? I want to make use of the Acrobat Reader. Okay. Okay. I think you saw just now what happened. The trigger for the normal thing is not happening. So I'm going to right click, open with. See? They block. They don't allow me to use either Acrobat. Sorry. So I got no choice. I have to use this one. Okay. Never mind. We just use full screen. Okay. Okay, so this is a topic on multiple linear regression. Okay, what we are going to cover today, we are going to cover very simple. We're going to cover simple linear regression. We're going to cover the basic theory of multiple linear regression. We're going to cover about the steps in handling the multiple linear regression analysis, the data presentation and interpretation. Okay, I've got 4 screen right now. I'm looking at 4 screen. Which one is working? I have no idea. Okay, but never mind. Okay, simple linear regression, we already covered this earlier. Okay, so we already covered this earlier. For example, the one that we covered that day, we were talking about age and cholesterol. Okay, as you all know, we are like coconut. The more mature we are, the more oily we are. Okay, we are like coconut. The more mature we are, the more oily we are. Okay, so the older we are, the higher is our level of cholesterol. Why? I do not know. Maybe you all know the explanation. Maybe inside your liver got more fat. Maybe your liver is more fatty. I don't know. Okay, maybe your diet is getting more fatty. Okay. So what is important here? Well, if you're trying to find the relationship between age and cholesterol, the analysis could be two, either correlation or regression analysis. Why? Because both are numerical variables. Okay. So correlation can give the strength of the relationship, whether it is weak, fair, moderate, or strong. But regression analysis can describe the relationship in more detail. Okay, you can even predict the outcome based on the risk factor, because regression will give you a formula. Regression will give you an equation on how to predict the value of the outcome based on the value of the risk factor. Okay. So in the both example, if we decide to do regression, cholesterol will be the outcome of interest. Cholesterol will be the outcome of interest because age may determine the cholesterol, but cholesterol cannot determine the age. Okay. Age may determine the cholesterol, but cholesterol cannot determine the age. Okay. So here's the example given. Okay. And inside the example given, as you can see here, the X is the risk factor. So X is the risk factor, therefore it is age. Y is the outcome. The outcome is cholesterol. So you can see here, the older you are, the more mature you are, the higher is your level of cholesterol. Okay, the higher is your level of cholesterol. Okay. I just realized. My apologies. I just realized I got two mouse. I was controlling the wrong mouse. Okay, so this is much better. Okay, why is this much better? I can see the audio bar. Okay. Okay. So to do the analysis is for simple linear grades. Now it is reconnected back. The nice thing about having multiple screen, you get to see everything. You get to see everything. Okay, Shafina says, okay, never mind. It's not you all, it's a year two. Okay, so we have the expressions here. Okay, we want to do simple linear regression between age and cholesterol. So age and cholesterol. So you can analyze. We click regression, linear. Okay, the dependent, the outcome is the cholesterol level. The risk factor is age. Okay, so it's very easy. So click on, so you can have a choice. We have statistics. What statistics you want? Okay, we can get the confidence interval. Okay, you can get the R square. You can get descriptive. You can get the collinearity diagnostic if you want to. Okay, okay. So click continue. Okay, the plots they give. You can get the all the plots to check for whether your table is okay or not. Okay, okay. You have the options. All these things we're going to cover later, but right now we're just going to do simple linear regression. So simple linear regression, we just want to have the cholesterol level and the age inside there. Click OK. Then we get the results, and the result is very simple, very clear. I'm going to shift it to the right side. Oops. Why shift to the right? Because my body is blocking the view. Okay, so you have the cholesterol level. You have the R is 0.331. We have the R squared. R squared is 0.109, which is quite small. So it's only 10%. And you can see the model. Okay. So we have the model here. The constant is here. Okay, the 95% CI is not coming out. I do not know which one. Okay. So we have the value here. Oh yeah, we got 95% CI. Okay. So we have the constant is 5.8. We have the regression coefficient is 0.058. Okay, and they are all significant. So we are okay here. Okay. So that is how we do. That is how we do simple linear regression. Okay, let's go back to the lecture at hand. So that is how we do simple linear regression. Very simple. Okay. So that is how we do simple linear. As mentioned just now, what is important? What is important is the regression coefficient here, the constant. Okay. So your regression coefficient goes there. Okay. This one is the regression coefficient. This 5.895 is the constant, it goes here. So y equals a plus bx, this constant is a. Okay, this constant is a. And as stated just now, everything is significant. So we are okay. So when we do the scatter diagram, we can get a slope like this. So for every increase of 1 year in age, there's an increase of the cholesterol level by 0.058. Okay. And if you increase by 10 years, there's an increase of 0.6 millimole per liter of the cholesterol level. Okay, okay. So the line that you got is called the linear equation. It's called the linear equation. How they predict that linear equation is based on the best line that will give the least difference compared to the observed value. Compared to the observed value. Okay. I'm going to change a bit my screen. I got a problem here. Okay, now much better. Okay, so that is simple linear regression. But today we are going to cover multiple linear regression. As stated before, okay, most of the events are determined by more than one factors. It is determined by more than one factors. So, for example, the cholesterol level, it could have been affected by other things also, not only your age. It could also be your diet. Okay. What do you have for breakfast today? Maybe you had nasi lemak. Maybe you had roti canai. Okay. Maybe you had chicken liver. So all these things can affect your cholesterol level. And like your exercise. You exercise regularly. Okay. Nice thing about PKP, we are at home in the morning. So we can immediately go and have a good exercise before we start to work. Okay. You can go and walk for 1 kilometer, 2 kilometers, okay, around your house before you start to work. Okay. Your socioeconomic status, maybe whatever you eat is determined by your socioeconomic status. Okay. If you are well off, you can go and buy udang, eat udang every day, eat prawns every day. How much is prawns nowadays? Okay. I just came back from Sabak Bernam, Sungai Besar. Sungai Besar, at the Pasar Borong, at the wholesale market, the udang, the prawns is 26 ringgit per kilo. The big one, the large size, L size. I never knew the prawns got size S, M, L. Okay. So these are things that can affect your cholesterol level. Okay. So if you look at each factor to the outcome, it will not be realistic. Why? Because each one of these things, they they are affected by one another. So if you're just looking at the age, there are factors that is being affected by others like diet, size, and socioeconomic status that is not being captured. If you look by diet only, cannot also. Exercise only, cannot also. Socioeconomic status, cannot also. As stated just now, socioeconomic status is very much tied to your diet. Okay, because what you can afford to buy, it depends on your socio-economic status. Okay, so instead of looking this one by one, you should look at all these things at the same time. You should look at all of this at the same time. Okay, so basically for multiple linear regression, you are running the whole thing at the same time. Okay, in this case, all these things are what we call continuous data in bracket. Why? Okay, age, yes, it is continuous data. We got no problem with that. Exercise, yes, because it is based on the number of hours that you exercise per week. So that is really continuous data. For the socioeconomic status, it is really ordinal data. For the socioeconomic status, it is really ordinal data. For the diet, it is also ordinal data. Eh? It is also ordinal data. Because we came up with a scale that make the person falls into type 1, type 2, type 3. Okay? For socioeconomic status, same thing. We come up with a scale, a measurement, they come up with type 1, type 2. So these are really ordinal data. Okay. So, but here, right now, in this analysis, we assume that they are continuous data or interval data. Okay. So, when we run this analysis, you will get the independent effect of the each of the variable after controlling for all the other risk factors. But of course, as mentioned just now, this one, all these things has got interaction. Okay, like exercise and age, there is interaction. Like diet and socioeconomic status, there is interaction. So we need to study the interaction between the independent variables, whether they are antagonistic or synergistic. Synergistic means they promote each other to become higher. Antagonistic means they antagonize each other to become lower. Okay, so it could be synergistic, it could be antagonistic. So as mentioned just now, we have independent effect. Yeah, which is confounded by other variables. For example, age. The younger you are, the more active you are. The younger you are, the more active you are. The older you are, the less active you are. Why? Because knee joint cannot support anymore. Okay. Last time when I was young, I was staying on the third floor of my hostel. In Sekolah Datuk Abdul Razak Sermat, Sedar. Yeah, got Sedar. Okay. Room B10. But if I forgot something, I just run up the stairs. It was very simple. 3 flights of stairs. I was flying to the third floor. Nowadays, at the age of 53, I just need to get something from the top floor. But I will not be able to do it by myself. Okay? So my house is 2 floors. Okay, I just need to get something from the first floor. I'll be asking my son, Afnan, can you get something for me? Why? Because my knee joint cannot support going up the stairs. I may have finished the Ironman way back in the 2014, okay, half Ironman. But now at the age of 53, after having a myocardial heart attack, okay, I can no longer do all that. Okay, so you are less able. So the effect of age and exercise, there is interaction. There is interaction. Okay, so as mentioned just now, older people less exercise, younger people more exercise. So it is not only the pure effect of age, but also the additional effect of from exercise. Uh, my Facebook, they end up with a blank screen. Okay, so but the line will continue. Okay, okay. So how about the independent effect, compounding effect with the cholesterol exercise? Okay, so also for exercise, it is also the other way around. Okay, not only the effect of exercise itself, but also the effect of age. Okay, less people who exercise less are older people. Therefore, the relationship of being higher cholesterol among less people is exaggerated by the effect of older age. Okay, so if we run the analysis together between age and exercise, then the confounding effects are eliminated, and you will get the independent effect of each independent variable. So you get the independent effect of age, you get the independent effect of exercise. Okay, so that is the beauty of doing multiple linear regression. So we mentioned about synergistic and antagonistic. Okay, let's see whether I can get it to display just nice. Okay, just nice. Okay, so you can see here we have the cholesterol and the diet and exercise. Your diet is on the higher side, you get increase of 1 unit of cholesterol. If you have one exercise for 1 week, okay, you will drop 1 millimole per liter of cholesterol. If you have less 1 hour exercise, then it will increase in the 1 millimole of cholesterol. So this one is effect of 1 unit. This one also effect of 1 unit. Therefore, if we combine this, we expect the effect to be combined or should be more. So 1 plus 1 should be 2. So here 1 plus 1 is become 2. But if you combine and you got more than 2. Here you got 2.5. So this one is what we call the synergistic effect. This one is what we call the synergistic effect. Then you have the other one. 1 plus 1, instead of getting 2, you get less, 1.5. Yeah, I'm sorry, my body is blocking the view. Haha, cannot lah. I cannot adjust. Okay, you get 1.5. Okay, I can switch off my ini. Okay, just let me switch off my. Okay, I'm gone there. So you can see there. Okay, it is 1.5. So 1 plus 1, instead of getting 2, you get 1.5. So there is antagonistic interaction. There is antagonistic interaction. Okay, so I hope that's clear. Okay, so let's go on to the next one. So this is the explanation about what is synergistics and what is antagonistic. Okay, so it's mentioned just now. We have synergistic and so this one, if you look at the notes earlier, it was 2.5. It was 2.5. So if 1 plus 1, you end up with 2.5. That is synergistic interaction. If 1 plus 1 instead of getting 2, you end up with 1.5. It is antagonistic interaction. Okay. So the basic theory of multiple linear regression is to explore the associated influencing or risk factors to the outcome. Okay. What are the factors that can affect the outcome? Then you can come up with a prediction model, and you can confirm a specific relationship if it is a confirmatory study. Okay. So let's not worry about that. Okay. I am blocking the view. Okay. So, okay. I think it's quite clear what we're trying to say here. Uh, each one of these are continuous data. Each one of these are continuous data. So because they are all continuous data or numerical data, so this is what we call multiple linear regression. This is what we call multiple linear regression. Okay. If this one is a mix of categorical and numerical data, then it is general linear regression. It is general linear regression. Okay. Why this thing come about? This thing come about because of the advent of general linear model. So when you have the general linear model, you have not only the numerical risk factors being put in, you also have the categorical risk factors being put in. But those with the categorical risk factors must code their categorical data properly. The data must be coded as 1 and 0. Very important. I do not know why, but this thing has never seemed to penetrate to the student. I keep emphasizing this every semester. If you are coding for categorical data inside multiple linear regression, it must be coded as 1 and 0. It must be coded as 1 and 0. 1 is for present, 0 is for absent. Okay. If it is polytomous data or polynomial data, okay, where there is more than 2 possible outcomes, then you have to create dummy variable. You have to create dummy variable. So to create dummy variable, that one we will cover later on. Okay. So the coding must always be 1 and 0. Okay. All right. Personally, as a student, when I learned this, I never learn the one with the categorical data. We only learn with the numerical data. Okay. But once we started to progress, that's when there's, there has been additional where people put in categorical data, but it is not really multiple linear regression. It is now known as general linear regression, similar like general linear model. Okay, so linear is nice because he came out with all these steps: step one, step two, step three, step four, step five, step six. Okay, right now I'm also having, because this thing is on, my Teams is on, so I'm getting alerts every now and then. So my apologies if it is affecting the class. Okay, so we're going to cover step one, data exploration, followed by scatter plot, then simple linear regression. Then we're going to do step three, variable selection. Then we check for interaction and multicollinearity. We look for model assumption and outliers. Then finally, the interpretation and data presentation. Okay, data exploration is nothing much. Basically, you want to confirm that every single one of your variable that you use for analysis are numerical data which are normally distributed. So you must check every single one of your variable, both for dependent and independent variables. They are all normally distributed. So for that, we run the command SPSS, we click on the button explore, then we get the answer whether they are normally distributed or not. So you can see here, I'm going to change screen. How to do it is very simple. Click analyze, density statistics, explore. Okay, right now we're selecting cholesterol. Okay, so the cholesterol level. So what we are going to do, okay, we're going to click on the all these descriptive. We're going to check for the presence of outliers. Continue. Okay, we can ask for plots. We can ask for normality plots. I don't like stem and leaf. I prefer histogram. Okay, continue. Click on options. Continue. Once done, you click on OK. Okay, immediately you get the answer here. We do it one by one. Cholesterol for cholesterol, age. We don't do everything one go because if there's missing value, it's going to affect the analysis. So we do all these things one by one. So we can see here the mean is 8.179. The median is 8.3. So since the mean and the median are similar, so chances are they are normally distributed. You can see at the skewness and kurtosis. Skewness and kurtosis are between plus minus 1. So the data is normally distributed. And you look at the KS test is not significant. The convergence window is not significant. So data is normally distributed. So for the cholesterol, you can proceed with multiple linear regression. So you must test for normality. You must test for normality before you, for every one of the variables, before you can proceed with multiple linear regression. Okay, so that is very, very important. Okay, next you do the between the risk factors and the outcome. Okay, so between the risk factor and outcome, you do simple linear regression. I already shown you just now on how to do the simple linear regression between cholesterol and age. Okay, you do this for all the variables. So since the risk factor is age, diet, socioeconomic status, and exercise, the outcome of interest is cholesterol level. So you run all this analysis between the risk factor and the outcome for every one of them, one by one. Okay, one by one. So you can do it. So it's 1.5%. So it's quite bad. Okay, so nothing much I can do about that. Okay, I think I already did the best that I could by having this kind of setup. If it still continues, nothing much I can do about it. But what's important here, is to look at this thing. Every one of these is significant. Age is significant, duration of exercise is significant, diet inventory score is significant, socioeconomic index is significant. Okay, you can see the CI. The CI does not cross the value of 0. The CI does not cross the value of 0. Okay, so it is they are all significant. Okay, so after that we do the next step, and the next step is preliminary main effect model variable selection. For the preliminary main effect model, okay, we have to do it together. Okay, so we have all these steps. We have all these steps. We have automatic, forward manual methods. Okay, so because right now these are the age of computer, so we do everything automatically. So we do forward, backward, and stepwise. Okay, so because the computers are faster, automatic methods can be done easily. So we can do forward, backward, and stepwise. So because this thing is can be done automatically, jangan kedekut. We do all three at the same time. Okay. Okay. How to do this? Okay. That's the beauty of this setup. Because the beauty of this setup, okay, I can just change screen. Okay, I can just change screen from my computer, and I don't have to worry about this thing on my streaming notebook. So that's the beauty of having this setup using the Atem Mini. I can just change screen with a click of a button. Okay. Somebody was asking me yesterday when I gave a talk about the minimum equipment required to teach online, and they saw the Atem Mini, and they asked why the Atem Mini is important. So the Atem Mini is important in the sense that it allows me to switch between input very easily. Okay. Okay, right now we are here. So now I'm going to demonstrate on the SPSS on how to do multiple linear regression. Okay, so we click analyze. Okay, regression, linear. Okay, just now we had only one age in year. So now we're going to add the rest. Okay, we have the diet inventory. We have the duration of exercise. We have the socio-economic status. Okay, these are the four variables. For the statistics, we have the estimates, we have the CI. Okay, you can click on all this. You can click on all this. That's what matter. You just increase the number of analysis that you get. But for me, I prefer to keep to this: the model fit, the R square, the descriptive, and the collinearity diagnostics. Click continue. Okay. Uh, Plots. I'm not going to do it now. I'm going to do it later. So let's not worry about that. So options, nothing much there. Continue. Once done, you click on OK. Okay. So here, these are the methods. So click on the method you want forward, backward, and stepwise. Forward, backward, and stepwise. So we're going to start with forward. Click OK. So under forward, okay, under forward, you can see here, this is the final output for forward. But you have a problem. The problem is this one. The socioeconomic status is not significant, but it is still included inside the final model, okay, which is not good. You want only the significant one inside the final model. So that is forward. Okay, that is forward. So we change now. We change our strategy. Instead of forward, you go backward. Okay, I know I can hear all the dirty jokes right now inside your mind. So don't say it out loud. This is a PG rated stream. Okay. So under a backward, okay, looking at the final model, okay, the final model that is included inside the backward one is age in year, diet, and the duration of exercise. What is missing here? Socioeconomic status is missing here. Okay, socioeconomic status is missing here. Okay, I just realized that my picture is not there. Sorry. Hi. No wonder I felt disconnected from all of you. Okay, so this is backward. Okay, everything is significant. It's inside here, but now the socioeconomic status is missing. Now click next one. Again, the regression. The only thing we change is this one, stepwise. The only thing we change is the strategy. Click OK. Again, you see here inside the third strategy. Inside the third strategy, the outcome is the same like the second one. Everything is significant. Okay. We have exercise, we have diet, we have age in year. Okay. The only thing is that is missing is your socioeconomic status. Okay. So these are the final model. So based on this model, we are happy that only three variables are significant, which is exercise, diet, and age in years. Okay. So now we are back into the PowerPoint. So I stated here we have the stepwise, we have the backward, we have the forward. Okay, so we have, you can see for the stepwise, that's the answer. Okay, for forward, this was the answer, but the difference is the socioeconomic status is not significant, it is still included inside the final model. For the backward, okay, we have the final model, which is everything is significant. Okay, and only age, diet, and exercise is significant. So you can see here the final model is cholesterol is equivalent to 7.297, which is a constant. Okay, this is a constant. This is a constant. 7.297 minus 0.54 exercise. So this is 0.54 plus 0.394 diet, 0.394 diet, and plus 0.033 age. This is, take note, this is 3 by the power of minus 2. 3 times 10 by the power of minus 2. That's why it is 0.033. Okay. So, based on the three automatic procedures, we agree that the model that we want to use is the one that comes from stepwise and the one that comes from backward.
Prof,
Yeah.
tanya, kan yang sekarang Prof tengah tunjuk ni, yang kat atas tu dia tulis model 1. Tapi Prof tunjuk kat kita baca yang significant value tu yang bawah. Apa
Yeah.
beza atas dengan bawah?
Okay, so okay, let me explain what is meant by forward, backward, and stepwise. Okay, okay. I believe there's something going on. Haha. 9:16. Today is 22nd. Wow, tomorrow I got to go to UKM. Okay. Tomorrow at 9 o'clock. I got to be in Bangi. I got to be in UKM. Aduh. Okay, let me explain. Okay, just now was Fatihah. Okay. Okay, let's look at here stepwise. What is meant by stepwise? When we do the strategy, uh, when we run the automated process, we have when we say stepwise, it is like dancing. Okay, step 1, step 2, step 3, you go back to step 2, then you go back to step 4. Okay, stepwise is you start with the most significant one. So the one with the most significant, with the one with the largest R square, was the socio-economic status. Okay, so when they run the analysis with the socio-economic status with the cholesterol, after that they add another one, the next most uh, largest R square, which was exercise. So they add the next one, which is exercise. So they are still okay, all significant. But as mentioned earlier, diet and socioeconomic status are most likely to be highly correlated with one another. There is issues of singularity because socioeconomic status is highly related to the food, the diet that you can take. So not surprisingly, when they run the analysis, there is an issue. So the issue here is suddenly the socioeconomic status become nullified by the presence of diet, and although diet is still significant, the socioeconomic status is no longer significant. You can see here. In fact, what is running inside my computer is only uh, what is necessary only, and yet it is still disconnecting. I'm going to try to switch off my Chrome. Maybe the Chrome is the one that is causing it to hang regularly. Okay, never mind. Okay, we do what we can. We do what we can. Okay, kita tak boleh perfect sentiasa. I'm only one man running this session without a technical support. Okay, for siaran perdana or big events like the Grand CPC, I have a whole team there running the show. So I got one guy on technical and so on and so forth. Here I'm doing both the technical part and the teaching at the same time. Alright, so you can see here, what happened here, they stop and remove the socio-economic status. So what happened, there was only 3 left. So there is only 2 left. You have only duration of exercise and the diet inventory. Then they add another one. Okay, the last one, which is age in year. Okay, so that is stepwise. Whatever that is not significant, they kick out. For forward, first round, they take the most significant one, socioeconomic status. Second, duration of exercise. Third, diet. You can see here, it still already become not significant. But instead of, because this one is just going forward, so they just add another one, which is age. Okay, and you can see that there's a problem here. The final model is not nice because got a value which is not significant. For backward, is different. They take everything in. Backward is different. The method is like rojak. Start with everything in. Then whatever does not taste nice, take out. Maybe you have the rojak, then you have sayur kangkung. Sayur kangkung is not nice, so they take out the sayur kangkung. Here, what is does not taste nice is the socio-economic status. So if it does not taste nice, it is not significant, we take out. So when we take out, so the next final model is significant. So that's why the model 1, 2, and 3 is not really the model itself. When you run the analysis, there is step 1, there is step 2. Okay, so this step 1, this is step 2. The strategy, we have the strategy of stepwise, forward, and backward. So I hope that's clear. So which value to take? The final value. The final value. And we take the model that is the most consistent. So as you can see, the model that is the most consistent is the one that has exercise, diet, and age. Remove the socio-economic status. And that is how we do it. Alright? Okay. I hope that's clear. Whoever that was I'm sorry, I'm not sure who was asking because I got the screen on something else. I got one screen on Facebook. I got one screen on OBS Studio. So right now, I'm just assuming that you all can hear me on Teams. Okay? Teams okay?
Okey, Prof. Faham.
Okay, thank you. Okay, Rahayu yang tanya. Sorry, Syah Fatihah. Okay. Uh, okay. Next one. Okay. So you already got the preliminary main effect model. Okay. To tell you all the truth, for the final year project, if you reach step 3, you all are okay already. If you reach the step 3, you all are okay already. Can you imagine right now on my Facebook, the questions they're asking, dia tanya pakai Predator laptop ke Prof? Okay. My laptop is, the one I'm using for teaching is Asus old one, i5. The one I'm using for streaming is the i7 MSI Leopard. Okay. All right. Okay. Okay. Let's go and look at the interaction. Okay. Let's look at the interaction. Right now, the sun is falling on me at the wrong angle. But yesterday, I tried to teach using with the curtains on, and the curtains are pink in color. So what happened was, inside the Zoom session, I was totally red in color. So I decided not to drop the curtain today to avoid me from turning red. Okay, so we have three variables that was significant. Okay, we have three variables that was significant, which is diet, age, and exercise. Okay, so there is possible interaction. So because it is possible to have interaction, we have to check for interaction. To check for interaction, we have to combine these two variables together. Okay, so we have to combine the variables together. Okay, then we will run the analysis using enter only with the significant ones. Okay, so I'm going to demonstrate to you on how to integrate using uh, SPSS. Okay, so again, because I'm using two notebooks here, I can change screen easily. So I'm going to my SPSS. I'm going to demonstrate how to integrate the variables. So basically, it is under transform compute variable. Okay, to make life easy, I'm going to give the label that is exactly like. That's the reason why I didn't use my notebook, my Asus notebook, because the keyboard no longer function. Uh, okay, let's put the age. We have the age. Okay, to create the new variable, you just times the new variable, the variable. So since this one is age exercise, so we have age times exercise. Age times exercise. Click OK. So you can see here. Sorry, you have a new variable created, age and exercise. So now I'm going to create some more. Transform compute variable. So we have the age and diet. So you put diet. Okay. Remove the exercise. We put in diet. So click OK. Okay. Again, we have created new variable, age, exercise, age and diet. So finally is diet and exercise. So finally it is diet and exercise. So we click analyze, transform, compute variable. Okay. So we put diet and exercise. So you just put diet and exercise. So we take out age, we put in exercise. Click OK. Okay. So now we have created 3 new variables for interaction. We have created 3 new variables for interaction. Okay. So we run the same thing again, the multiple linear regression. Multiple linear regression. So we click analyze, linear, regression, linear. Okay. So we take out the one that is not significant. So the one that was not significant was socioeconomic status. We take out. Remember, we are testing for uh, interaction. So we take one by one. So first we take age and exercise. Method we change to enter. Method we change to enter. Click OK. Okay, we look at the model. Okay, we look at the model here. When we do enter, there is only one step. There is only one step. So inside here, the step, as you can see, age and exercise not significant. So there is no interaction with age and exercise. So take out. Run again. We run again. So we take out age and exercise. Regression linear. Okay. We take out age and exercise. We put in age and diet. Click OK. Now we look at the age and diet. Age and diet not significant. Alhamdulillah, it is not significant. So we take out. So click analyze. Regression linear. We take out the age and diet. We put diet and exercise. We put diet and exercise. Click OK. Okay. We just scroll direct to the model. The final model is okay, exercise and diet not significant. The p-value is larger than 0.05. It is 0.733. Okay. So since it is not significant, so there is no interaction. So there is no interaction. Okay. Let's go back to the PowerPoint. Okay. Okay. So you can see here, we already shown you how to integrate the variables, and we shown you how to check for interaction. And as I showed you earlier, none of the variables were significant. Tak ada satu pun variables yang significant. So now the variables are significant. So we are okay. We are okay. So we already okay. That is how we check for interaction. Next, we have to check for multicollinearity. Doctor, what is multicollinearity? When the variables are one and the same. When the variables are one and the same. We stated earlier just now, socioeconomic status and diet, most probably they are the same variable. We covered the lecture last week about multiple logistic regression, about race and religion. Okay, so that is issues of we are trying to do two things at the same time. We are trying to teach online. You're also trying to teach on your teams. Okay, does not matter. Okay, let's not worry about the Facebook one. Let's worry about the student on Teams. Okay, so please take note. This thing, the issue here. If you have issues of multicollinearity, the width of the 90% CI will be larger. The width of the 95% CI will be larger. The p-value should be larger. Therefore, the models will not be stable. Remember what we had with the multiple logistic regression? With the multiple logistic regression, if we have that, what happened was the R square, not the R square, the standard error, okay, the standard error inside the M log R would be larger than 5. Okay, so here inside the multiple linear regression, it will affect the CI, it will affect the p-values. Therefore, we have to check for problems of multicollinearity. Okay. Okay, hopefully my face is... Right now, I just realized the sun and the LED light, the sun is much more powerful. Okay, let's check for problems of multicollinearity. Okay, remember just now we checked for collinearity diagnostic. What happens when you check for collinearity diagnostic? You will get the VIF and the tolerance. You get the VIF and the tolerance. So basically, we have two sources of reference here. One is IOP. So for IOP, you look at the VIF. If the VIF is larger than 10, you have problem. You have problem. Means there are issues of multicollinearity. There are variables that you may have to drop because they are highly correlated with one another. Issues of multicollinearity. So here you can see that you don't have issues of variance inflation factor. So VIF is a variance inflation factor, okay, and none of this is larger than 10, so you all are okay. For tolerance, the cutoff point is 0.6. The cutoff point is, if it is less than 0.6, then you have issues of multicollinearity. Okay, if tolerance is less than 0.6, you have issues of multicollinearity. Doctor, where you get the 0.6? You please refer to what is Chan's notes. So what is Chan's note from the his write up on linear regression. You can check it out on my website. Okay, Wai Chan discuss about this. If it is less than 0.6, you have issues of multicollinearity. Okay. Okay. So on expresses, how does it look like? Okay, I keep forgetting that I have no need to do this. I just have to do this. Okay. So you look here. Okay. Let's scroll up to the final model. So our final model was up there. Okay. This one was the MLR. Okay, this one is the forward method. Okay, this one is the stepwise. Okay, so you can see here inside stepwise. On the right side, you have the collinearity diagnostic. Okay, because when you run this now, you click, you get the tolerance and the BIF together. So you can see here, they are not significant. The value of tolerance is larger than 0.6. The value of the BIF is less than 10. So anything larger than 10, you have a problem. All right. So that is how we check for multicollinearity. Okay. Jump. Okay. I keep forgetting. I keep pressing the wrong button. Okay. Okay. That is the story about Okay. So now you have checked there is no issues of interaction. There are no issues of multicollinearity from your preliminary main effect model. So now you are going to check for the model assumption and outliers. Okay. To check for the model assumption, okay, first you have to make sure the assumptions it is random sample. So you're doing sampling method, you must make sure you have when you select the sample, they have equal chance of being selected. That's why it is very important to be random sample. Then you have to check for linearity, independence, normality, and equivariance. Normality you already covered earlier in the earlier part on whether it's normal or not for a single variable. But here when we talk about normality, we are talking about multivariate normality. Okay. So we're going to check at linearity, independence, normality, and equivariance. All of these are done by using residual plots. When they say residual, what they're referring to, you have the equation. So when you have the equation, you can calculate the predicted value of the outcome. So the difference of the predicted value of the outcome from the formula against the observed value. That is the residual. That is the meaning of the residual. So I'm going to generate the residuals. So I'm going to generate residuals based on our final model. Remember our final model? It was age, diet, and exercise. Okay, age, diet, and exercise. So based on the age, diet, and exercise, I'm going to generate the residuals. Then we are going to discuss what is the residuals. Okay. Okay. So what is important? We are going to get the unstandardized residuals and the unstandardized predicted values. Okay. So we're going to save all these values. Okay. I'm going to do it on SPSS. Okay. How to get all these things? You just click regression, linear. Okay. Remember what I said? Only this thing. We have only age in here, diet, and exercise. Because that is the significant ones. Next. Okay. We want to save. What do we want to save? We want to save the predicted values and we have to save the residuals. I don't want to do this thing too many times, so I'm just going to do it only one time so that we get both the unstandardized and standardized for both the predicted values and the residuals. Click continue. I click OK. So you can see here inside SPSS, we have generated 4 new variables. Z means standardized. Z means standard. So we have here, this is the predicted value of 7.32. This is the residual, minus 7.2. Okay, remember what I told you just now? We are coming up with the formula. Based on the formula, you're going to come up with the predicted value of the cholesterol level. So this is the predicted value of the cholesterol level. Okay. What is residual? Residual is the observed value minus predicted value. Right now you cannot see that, but I'm going to change that by moving the cholesterol here to become here. Okay. So now what happened now? You can see this is the cholesterol level. This is the predicted value. This is the residual. Okay. So it is the observed value minus the predicted value. So if I do like this, transform, compute variable, okay, I'm just going to give a number residual, resid. Sure. Sorry. Aduh, I'm getting old. I'm typing on the wrong keyboard. Ah, I'm getting old. I'm really old. Okay, so we're going to have. Okay, remember I said just now? It is the observed. So the observed is the cholesterol value minus the predicted value. So answer that predicted value. You click OK. So what happened now? Okay, you can see here the residual that we calculated, the difference between cholesterol level and the predicted one, they are similar like the residual one. So minus 0.72, minus 0.72, minus 0.7, minus 0.7. So you can see that is the meaning of residual. The difference between the observed outcome and the predicted outcome. Okay, please remember that. Residual is the difference between the predicted outcome and the observed outcome. Okay. Okay. So that is how we get the residuals. Okay. So what do we do? we want to plot the table. So how do we plot? Okay, there is the explanation. Okay, there is the explanation how we get the predicted value. Okay, I like Ayub's notes. His notes are very good. So you can see here, this is the predicted, this is the observed, and this is the residual of predicted and the observed. Okay, so as mentioned just now, this is the data that you get, the observed data. This is based on the statistical model. The formula. Doctor, can you do it without getting disconnected? Can. I have to buy OBS Studio. Not OBS. I have to buy Atem Mini Pro. So I will be streaming direct from the Atem Mini itself. But the one I tried to buy that day, Shopee rejected because they say I already exceeded 5,000 ringgit for that month. Ada, kita nak beli barang pun dia tak bagi. So I had to buy the cheaper one, which is 1,600. 1,650. I got discount of 30 ringgit. Then I got another cashback on another 165 ringgit. Okay lah. But it is useful. As you can see, I can teach directly without worrying about changing screen on my notebook. But I just have to remember which one is which. Okay. So now let's do the scatter plot between the unstandardized predicted value and the unstandardized residuals. Okay, how to do this? We do the scatter plot. We do the scatter plot. Okay, please remember the outcome is the residuals. The risk factor here is the unstandardized predicted value. So it's predicted value and residuals. Okay, right now I'm on SPSS. I'm going to click on analyze. Okay, I'm going to do scatter plot under graph, legacy dialog. Okay, I have a problem. My okay, very sorry. Uh, because it's first time I'm doing this. So I was not really prepared for the eventuality. Okay. Give me a minute. The problem was I did not have a backup battery for the. Okay. Wait a minute. What happened was I was not prepared for this. The the webcam ran out of battery. Okay. So there was no picture coming out from the webcam. Not webcam. The GoPro. Okay. My apologies. This is my first time I'm doing this. Using the GoPro. So I'm not really knowledgeable about This. Okay, nothing much I can do about that. The GoPro is gone. The GoPro is gone. Okay, so I have no GoPro. Okay, so it's the first time. So now at least I'm aware about the limitation of the GoPro. Okay, very sorry about that. Okay, okay, let's go back to simple scatter diagram. Define. So the X here is my, okay, remember we want to do unstandardized predicted. So unstandardized is the X-axis. The residual is residual. Unstandardized residual is the Y. You click OK and you come up with this. Doctor, how come not the same? Okay, it is not the same because we don't have the line. What line we don't have? We don't have the line at 0. Okay, so the line at 0, to get that line is very simple. Okay, double click. Oh, okay, I'm glad this thing work. My SPSS on my MSI no longer works. The notebook was updated to the latest version of Windows 10. After that, it no longer works. Okay, so you can see here inside there, there's a vertical line. You can ask for the vertical line. So they say vertical line you want it to be where? It can be at 0. What kind of line? You can set the line to become putus like this. Change the color, become red. Apply, close. See? Now you have the same line like what they have inside there. But the line is not important. The line is not important. What is important is to look at the large values that is the furthest away from the red line. Okay, what is important is to look at the largest value from the red line. Okay, so you can see here. Okay, uh, okay. So for this one, in this example, they are trying to show for a predicted value of 7.3, the residual is minus 7.2. Sorry, minus 0.72. Okay, so you can see here, here 7.3, that's a 7.3 value. The residual is minus 0.72. Okay, so what is important there? That all the lines are distributed along 0. All the dots, all the residuals are plotted along the dots, and this thing, when you draw a line, they are all equal. So the variance are all equal. Okay, so you can see here. So inside a simple linear regression, you are looking at homoscedasticity of all the dots along with the regression line. So inside multiple linear regression, this is where is the regression line now. All the dots here are distributed equally, okay, along the regression line. So along the 0 line. So this 0 line is inside the regression model. Okay. So you are checking about the model assumption. Okay. So inside there, you're looking at the linearity. So you can see here we have linearity. there is linearity of the residuals. They all distributed along the line homoscedasticity. Okay, so there are three types of residuals plot that we have to do. One is residual versus predicted. There is linearity, and there is equal variance of the residuals. So there is linearity, and there is equal variance of residuals. Okay, so let's look at the next one. We're going to look at the, okay, this one already discussed with you just now. They are all equal. Okay, they're all equal. They are distributed nicely like this, so we are okay. If it's not like this, okay, that's the what for the model assumption. If we have this kind of line, we have linearity. So it meets the linearity assumption. Okay, you can see here, it meets the linearity assumption. Next, we have equal variance. I stated earlier just now, this one and this one, ours is this one and this one. So equal variance assumption is met. So equal variance assumption is met. So we have no problem. Okay. Next, we have to do a histogram plot of the residuals. Okay. My phone is keep flying. Okay. Basically, it is my gang on PalmX giving a shout out on me teaching statistics online. uh, thank you, PalmX. Sorry about that. For the residuals, okay, it's very simple. I'm going back to SPSS. Remember, this is the residuals. This is the residuals. Okay, so we're going to plot based on this residual. We're going to do a histogram. So chart, legacy dialog, histogram. So what is the variable? Receipt. Answer dash residuals. Answer dash residuals. Okay, we want it to display a normal curve. Click OK. See? Beautiful. Okay, beautiful. Please take note, the mean is 0. Please take note, the mean is 0. It is up to 15 decimal point. It is up to 15 decimal. The mean is 0. So we are okay. So we are okay. So you can see we have normal, the residuals fits the normal curve. Okay. All right. So let's go back to the. Okay. Okay. So we already covered that. Okay. Next, we have to do one by one. Haha. Doctor like this die lah. I know. Don't worry. It is very simple. So we have to plot the residuals. We have to check the linearity between the residuals and the age, residuals and the diet, residuals and the exercise. So very simple. I'm going to show you the shortcut way. Shortcut way is simple. Click graph, legacy dialog, scatter diagram, simple scatter, define. Okay. So this one, okay, take out this one, put in age. Click OK. Okay. See? Then again, run the thing. Same thing here. You just double click. Then you click at the middle line, get 0. Okay, lines. This line, red in color. Click apply, close, you're okay. Okay, so again, it fulfills there is linearity. between H and the residual. So click graph, you can see dialog, scatter, simple scatter, take out the H in here, put in the second one. The second one is what? The second one is exercise. Click OK. Okay, you get the same thing again, double click. This was when I realized that they did not have the minutes. They just based on the response of the respondents, how many hours they exercise per week. People tend to exaggerate the number of hours of exercise per week. I cannot, because I got everything captured by my Garmin. So my Garmin will tell me exactly how much exercise I have every week. Okay, define. Okay, take out this one, duration exercise. Okay, we already have age, we already have exercise. So the last one is diet. Diet. Next, click OK. Okay, again double click. Click on the vertical line. Line is putus. Red in color. Click apply. Click close. Click OK. Okay, so that is how we check for linearity between all the risk factors and the residuals. Okay, and with that we are okay. Okay, so for the outliers, we need to use standardized residual, and the standardized residual should not be larger than 3.0. Okay, so we are going to plot again between the standardized residuals and the unstandardized. Okay, unstandardized predicted value. Okay, as stated earlier, I know already I'm going to do this. So I already prepared it earlier. Okay, so I'm going to take out this one, the die inventory. So I'm going to put in the standardized residuals. Okay, we have here the standardized residuals. I shift to A, I need to, I got it wrong. So standardized residual goes to Y. The unstandardized predicted value goes to X. Okay, click OK. Again, we get something like this. Double click at 0. You have that horizontal line. Okay, I'm going to set in red in color. Okay, close. So you can see here, the largest value is still less than 3. The largest value is still less than 3. So we are okay. Okay. So means our model okay. Our model is okay. Okay. So if the data points are beyond plus minus 3 means plus and minus of the 3, they are outliers. So if you have a problem of outliers, chances are there are issues of data entry, wrong data entry, or they are not supposed to be part of the study. So please check. So please check if you have issues of that. Okay. If there is no entry error, then you have to get someone who is good in statistics to help you with your analysis. Not me, not me. Okay, the final thing. Okay, I need to remove myself. Why I need to remove myself? Because I'm blocking the view. Then. Okay, I'm missing again. So this is the results. So we have the SLR. The SLR here is not single lens reflex. It is not straight leg race, but this one is simple linear regression. So you can see inside simple linear regression, you have the significant variable, The significant variables were age, duration of exercise, diet, inventory score, and socioeconomic index. Okay, these are the answer. This is the regression coefficient for simple linear regression. But when we proceed with multiple linear regression, suddenly socioeconomic index is no longer part of the picture. Why? As stated earlier, socioeconomic index and diet inventory score are very much correlated with one another. So not surprisingly, one of them was dropped out, which is the socioeconomic index was dropped out. So you can see here in the final model, the independent effect is much less compared to the crude effect. So you can see here for the age, it is 0.03, and the crude effect, this is what we call the adjusted beta, the adjusted regression coefficient. So the adjusted regression coefficient is the independent effect, it is 0.03, compared with the crude effect, which is 0.06. It is much less, but we know already these are purely from age. For duration of exercise, from it is now minus 0.154. Previously, it was minus 0.62. Therefore, it is much less compared to the other one. Okay. Okay. So you can see here, this is the independent effect. This is minus 0.3. Sorry, this is 0.39 for diet inventory score compared to the crude effect is 0.45. Okay. So it is adjusted. You can see here the CI is not including the value of 0, so therefore they are all insignificant, and the p-value is all significant. Here is the t-statistic. I will not put it as negative. Yeah, I will not put it, because this t-value should not be negative. Okay, so as mentioned here, this is a simple linear regression. This is multiple linear regression. What is important? What is the r squared? The r squared is 0.69. Okay, again, I can hear all the dirty jokes at your head. Okay, this is just the r square. Okay, so this is the r square is 0.6. That means 69% of the effect on cholesterol can be explained by these three variables, which is age, duration of exercise, and the diet inventory score. Okay, model assumptions are met. We already tested that. Okay, we already tested that. The model assumptions are all met. There is no interaction between the independent variables, and there is no multicollinearity problem. We already checked the VIF, we already checked the tolerance. There is no issue of multicollinearity. We already run the interaction. There is no interaction. Okay, so again, as stated here, this is the crude regression coefficient. This is the adjusted regression coefficient. And this is the final model. This is the final model. So cholesterol level can be rated by the constant of 7.30 plus 0.03H minus 0.54 exercise and plus 0.39 diet. And you can explain by saying that there is a significant relationship between age and cholesterol level. Those with 10 years older have cholesterol level higher for 0.3 millimole per liter. Okay, this is CI 0.1 and 0.6 millimole per liter. Okay, doktor, how come it's different? Kali 10. Kali 10. There is a significant linear relationship between duration of exercise and cholesterol level. Those having 1 hour less exercise per week have a cholesterol level higher for 0.54 millimole per liter. So basically, you are supposed to exercise. Just go ahead and exercise. I know there's a lot of haters against cyclists right now. Okay, just exercise. Just don't break the law, don't break the traffic law. Cycle at the place that you're allowed to cycle and keep to the left, please. Okay, and for diet, you can see level in the study. Why? Because the R square is 0.69. Remember, the R square is the coefficient of determination. The R square is the coefficient of determination. Okay. Okay. So with that, I think we're done. Okay. And that is how we check for all this analysis. So these are all the steps. Step 1 is data exploration. Step 2 is the scatter plot and simple linear regression. Step 3 is the preliminary main defect model. Step 4, we check for interaction and multicollinearity. Then we check for step 5 is model assumption and outliers. And finally, your step 6, which is interpretation and data presentation. Okay? Okay. This is very important. Okay? This is very important. I know this is a mistake done by students, PhD, everywhere. Not only medicine. Everywhere. So please always remember, the lower risk is coded as 0, the higher risk is coded as 1. The lower risk is always coded as 0, the higher risk is always coded as 1. Okay? If you have more than 2 variables, you have to create a dummy variable. If you have more than 2 possible outcome, it is a multinomial or polynomial, or it is like what the right people call polytomous outcome. Okay, so for the polytomous outcome, you have to create dummy variable, because the only code that is accepted inside the multiple linear regression is only 0 and 1 for categorical data. The only code that is accepted inside the multiple linear regression for categorical data is only 0 and 1. So you have to create dummy variable. Okay? Okay, so and with that, I think we are done. The rest are just explanation about dummy variable. Okay, thank you very much. Okay, so I wish I could change to my camera, but my camera does not work already. Okay, why it does not work? It overheated. Okay, so that's my camera. Okay, this is my camera, and as you all can see, it still does not work. Okay, oh, it's working. Yay, it's working. Yay, it's working. Okay, uh, it's working, but it is recording also. So better stop. Oh, now it's recording. Okay, so whatever it is, I'm done. Okay. Okay, you can see there's a big me, there's a small me. Okay. I'm going to shift back to the class. Okay, I am now open for question. Any question from the class? If you cannot understand this, then you may be in a bit of trouble, because simple linear regression is coming out in the exam. Okay, multiple linear regression is not coming out in the exam, but because we are asking for simple linear regression, so therefore you should be able to understand a bit from today's class. Okay, you don't understand the multiple one, it's okay, but what is important is the simple linear regression. Semua okay? Okay, semua senyap. Fatihah, you okay?
Prof.
You expert kan, should be okay lah.
Mana ada. Prof, cuma nak tanya.
Ah,
Kan tadi kan kalau age tu, kita buat dalam multiple linear regression ni kan?
ah.
Numerous punya data. Katakanlah kalau kita buat age dalam multiple logistic regression, boleh juga kan?
Kalau outcome dia adalah yes or no.
Yes,
Ah.
okay.
Yeah. So that's why
Satu lagi,
the decision whether to use M log R or to use MLR, it depends on the outcome. If the outcome is continuous, it's MLR. If the outcome is dichotomous categorical, then it is M log R. Okay, proceed, Fadia.
Kalau dia campur kita guna multinomial ke Prof atau macam mana?
Campur.
Contoh,
Kalau
ada setting
if the outcome is categorical, multinomial. So means example, if the outcome is underweight, normal weight, overweight, then kita gunakan multinomial logistic regression.
Oh, okay.
We always look at the outcome. Alright. I just perasan dalam video ni I duk pegang perut ni. Okay, the rest are okay Okay, our cyclist Zul, are you okay? Siapa ni?
Okay, Prof.
Okay, alright. Okay, so if there is no more, then I'm going to stop the session now. Because
Prof.
yes.
Boleh tunjuk QR code tak? Saya tak sempat scan lah, Prof.
Kejap kena cari balik QR code. Okay, kejap Dah lupa, ada dua mouse. Mana mouse nak tekan pun dah tak ingat. Okay. Okay, I'm going to share screen now. Boleh nampak
Okay, done, Prof.
Okay, thank you. Okay, so it is done. So we have attendees Ahmad Farid Nazmi, last one. Okay. Okay, so with that, we are done. I'm going to stop the recording first. I always forget to do that. Stop recording first. Stop recording. Stop recording. So recording is done. Dismiss. Hide share option. Okay, I'm going to end the meeting. Thank you very much. Have a good day.
Thank you, Prof.
Facebook lah nak off. Okay guys, so thank you guys for the Facebook. Alright, yes Ustaz, terima kasih. Ini bilik produksi and live video. Thank you very much.